So what we're going to work on today is how to add or subtract rational expressions. The key is that you understand that adding and subtracting rational expressions, which are fractions, are going to follow the same rules as if we were adding numerical fractions. Okay? So if we wanted to add 2/3 plus 4/9, we can't add them as they are written because they have unlike denominators. So what we need to do is convert the 2/3 to 6/9, which is our LCD, so that we can add the numerators, carry over the denominator, and get 10/9. If we have variables in our denominator, it's the same concept, except that we can't combine the a plus b is to ab because we're adding, so we want to write it as a plus b. Now, how do we add or subtract rational expressions? So let's lay out the steps and then we'll go through some examples. Step 1, if necessary, determine the least common denominator. Which we're going to call the LCD. Okay? Obviously, that's if each of the denominators have a different expression there. Convert, if necessary, each rational expression into an equivalent fraction with the same denominators. Okay, this is done by multiplying the numerator and denominator of the fraction by the appropriate factor. Okay. Step 3. Scroll this down a little. Whoop. There we go. If there is no common factors amongst the denominators, and you'll see this when we get to an example. Then the LCD is denominator times denominator. So for example, if your denominators were 7 and 9, 7 and 9 don't have a common factor, so your least common denominator would be 7 times 9, which is 63. Okay. Now, as we saw in the do now, you're going to add or subtract the numerators and carry over the denominator. Now, the only thing you have to be careful of is if it is subtraction, and you'll see this, you have to distribute the negative sign to the numerator, to all the terms of the numerator. Of what is being subtracted. Okay? And as we've seen throughout, simplify if possible. Okay? So let's go through some examples, and hopefully this will all make some sense. All right, in the first one, we see very simply that we have the same denominator, so we just add to get 12x squared over 3x, which is 4x when we simplify. In the next one, and this is what we were talking about by distributing, one of my suggestions is you write your numerator after you've distributed. So it's minus 4x minus 3. The most common mistake in this situation is where we distribute the negative sign just to the first term. So now we get 3x plus 2 over 3x squared minus x minus 2. The numerator can be, the denominator can be factored as 3x plus 2x minus 1, so that we're left with 1 over x minus 1. Okay. Now we'll get into problems where we want to, where we need to change denominators. Okay. All right. Let's go here. All right. So now we have different denominators. My suggestion always is to identify the LCD, which is 6x squared. So that means the first one will stay as 6x squared, and this one has to be multiplied by 2x over 2x to get me 14x over 6x squared. And simply put, I just write the numerator as 14x plus 3 over 6x squared. Remember, you can't cancel pieces, so the x and the x squared do not cancel. The 6 and the 14 don't cancel because it's got to divide into the 14 and the 3, which I could do. I can't do because they all don't have a common factor. Okay? This one, my LCD, is 10x squared. So that stays. This has to become 10x squared. How do I do that? Again, 2x over 2x. So this becomes 12x and 4. I write as 12x minus 4 over 10x squared. Now here, 12, 4, and 10 are all divisible by 2. So I can factor out a 2 from each and get 6x minus 2 over 5x squared. Okay. Next one, my LCD is 3a. So the second fraction stays. I have to multiply the first one by 3 over 3. So that's 3a. That's 3a plus 3. So I get 4a over 3a, which is equal to 4 over 3. LCD for n. So I have to multiply the first one by 4. So I get 4n plus 12 over n for n minus 4 minus 8n over 4n. That gives me 4n plus 12 minus 4 plus 8n over 4n, which is 12n plus 8 over 4n. All of them are divisible by 4, so I get 3n plus 2 over n. Okay. All right. Next one, my LCD is 21y to the fourth. So one of the things you could always do is write out your denominator. The first one needs to be multiplied by 3, and the second one needs to be multiplied by 7y squared. So I get 9 in the first numerator, and I get 14y squared in the second. So I have 9 plus 14y squared over 21y to the fourth, and nothing can be simplified there. Now, the last one is an example, what I was talking about, where I don't have a common factor for any of my denominators. Just going to use a different color here. So if that is the case, my LCD is d minus 1 times d plus 2. So each denominator is going to have d minus 1 and d plus 2 in it, which means the first one I need to multiply by d plus 2, and the second one I have to multiply by d minus 1. Okay. Now, I do want to distribute so that I get 3d plus 6 and 2d minus 2. Now I want to put this all together. Do not distribute in the denominator because it may highlight something that you can simplify. So 3d plus 6 minus 2d plus 2, okay, which gives me d plus 8, and now I have d minus 1 over d plus 2. Okay, the reason I don't distribute in the denominator is in case I was left with something that I can cancel, I would do so. Okay, so again, today was adding, subtracting rational expressions. Remember, as we've always done with fractions, you need like denominator to be able to do so.